indicated to use the district name as a reference for dissolve, it now combined all the communes that belong to the same district into one. So now we have a map of the different districts within Phnom Penh. Any questions about dissolve? Okay. Great. So next we have buffer. Again, quite straightforward. It draws a buffer or a boundary around existing polygons. So it creates a polygon that surrounds the geometry, and it allows you to indicate how big that boundary should be. So for points, it's going to be a circle. For lines, it's going to be like a thicker version of that line. And for buildings, it's going to extend that and for polygons, it's going to extend that shape by adding a padding to it, such as this one. So in Python, again, it's pretty straightforward, where you just do your data dot buffer and the distance you want to draw around it. Okay, so here I'm using the default projection, which is EPSG 4326 or WGS 84. Oh. Oh no, where's the buffer? Saan ba yan? Ayan. There. So the plot. Why is it not showing here? So here we can actually see from our original data set, which is the communes, and now we created a buffer around it at 1 kilometer or 1,000 meters. So you can see that blue line representing that buffer size. So again, note here that we want to project our data using the correct projection or EPSG so that we can use the correct metric system to indicate the size and measurements that we are using. Oh, next we have centroid. So this is just getting the geometric center of a point or a polygon. So if you remember a physics experiment where you tie a piece of paper to a thread, so you can find the center of a irregularly shaped object. So it's the same with this one. And again, we can also do it in one line in Python. So here, from our commune, we can use .centroid to get the center of each communes. There you go. So if you overlay this with this one, it's going to show you the geometric center of each commune. Um, so what that actually returns, if you don't plot it, is is a series of geometries that you can save as a new column in your data set. All right. Any questions before moving on to the next section? Yeah. So next we have simplify. So basically, as the word suggests, it's making your polygons simpler by removing extra points or edges, so that it still gives you a resemblance of the shape, but it has less corners, which makes it a lighter data set. So just note that the more complicated the shape is, the more corners or vertices it has, and the bigger or heavier your file will be. So simplify is a useful tool to minimize the file size of your dataset. But just note that too much simplification will actually distort your data already. So if you look at the example here, you see that it's oversimplified, and that it no longer follows, it doesn't resemble the original shape anymore. So there's still a semblance of it, but as you can see in this part, the bend is no longer captured by your by the red line. So that is an effect of simplification. Wala na naman siya. Ayun. Break. Okay. Alright. 4 o'clock. Yeah. Okay, 3 o'clock. Okay. So let's just go over this example. So here I'm setting tolerance. So what this means is how simplified do I want it to be? So the higher the number, the more simplified the output will be. So here I'm using 0.001. And as you can see, it still sort of resembles the boundaries for the province. But if I do 0.1, it's going to look a lot more different. Let's say 0.1. Okay. Let's. Huh? It's in meters. Okay. So it's rejected. There. So see here, the bigger number I input, the more weird the shapes become. And that is because you have low, you're being too lenient on how it's being simplified. So here, let's try to see what happens if I set it to 100. And as you can see, it goes back to a more familiar shape of the province. Break. Okay, so I know that's a lot of activities and information. So we can actually go on 15 minutes. Okay lang, so we can actually go on a 20-minute break. So feel free to grab coffee. Okay. Where is my mouse? Oh, so moving. Wala na pala. Next na pala. That's the last. Wala. Ay, oo nga. Yeah. Let me just fix this first. Okay, so going back into our notebook. So just a recap of what we've covered so far. Let me find my cursor first. There. So we started off with some setup and downloading the libraries that we were going to use, as well as how to read different files as a geospatial data set in Python. So we tried it from vector files, it's just geo package and shape files, as well as CSVs. We went over how to use projections in Python so that we can correctly display and measure area and distances. We've also gone through spatial predicates, the most common one, which is intersects, which allows us to do spatial joins, as well as some of the geometric operations. So how we can dissolve and combine smaller polygons into bigger ones, how we can buffer and extend the geometries, how to find the center of each geometry, as well as how to simplify or minimize the data size. So next up, we have area calculations. So I quickly demonstrated this earlier. Let's replace this again with the correct one. Okay. So, so here, again, we have the communes underscore GDF. And what we want it to do is get the area of each commune in square kilometers. So apologies earlier, my conversion was wrong. It's supposed to be divided by 1 million. Yes. So here, in this, it'll show you the size of communes in square kilometers. As you can see, it's quite small because I think if I recall correctly, communes are the smallest administrative boundary in Cambodia, if that's correct. So yeah, we're expecting smaller numbers for this one. But we can also remove this division by 1 million to hectares and divide it by 10,000 instead. So it will show us the size in hectares. So the result of this should be the area of the commune in square meters divided by 10,000. So that converts the square meters into hectares. So you can see here, we have a bit more reasonable range of numbers. So from 75 hectares per one commune, does that sound about right to everyone? I'm not sure how big communes are. Right. So next, we've been doing this quite throughout the note, which is plotting. So essentially, there. Essentially, it's displaying your data as plots, so you can visualize your geospatial data set. So here again, I'm just dissolving our communes into one single polygon to represent Phnom Penh. And next, so we will use this, so we will use this dissolved polygon as our base map or reference point. um, so here, essentially just shows you Phnom Penh. And then next up, we can add in POIs. So here, um, yeah. Okay, here we have, again, we're setting Phnom Penh as our base. And then we are adding our POIs data into this new map. So if you run this cell, it will show you all of the POIs across this province. So you see a lot of it is clustered in this particular area. I think this is more of the central part of the province. There. And next up, we can actually color code these different points so that it's easier to identify what they represent. So again, we have the base map for Phnom Penh, and now we are coloring our POIs based on the name. Oh, this should be F class. As you can see, now from here, we did two things. So first is we used F class or the type of POI in the data set. If it this indicates if it's a bank, a school, a shopping center, or a hospital, etc. And color codes the points based on that. Another is we set the marker size. So if you notice, the markers here or the points are much smaller than the ones here. So it tends to cluster and cover more area than it should. So making it smaller actually makes it a bit more easier to read. So as you can see, there are still a lot of POIs on this map. So the next thing that we can do is there. We can actually make the map bigger and add in a legend to help us identify what the colors represent. Oh no, where is it? Okay, there. So since we have a very long list of POI types, we have to scroll up to see the map. But here you can see that it's colored based on the class again. So orange represents these classes of POIs. So for the blue ones, it can be art centers, artworks, ATMs, attractions, bakeries, etc. So you can be more strict about this, where one F class will be represented as an individual color. But since in this particular data set, there are too many classes to account for, it just defaults to using the same color for multiple classes. What we can do is actually filter it to specific ones. So let's say I'm here in Phnom Penh and I want to look for all the banks and ATMs that I can access in the province. So I have here the same plotting code as earlier. But the difference is here I am filtering the POI data that where F class should be either bank, classified as a bank, or as an ATM. So when I run this, it will come up with this particular map. So you can also do more advanced settings to this, where you can personalize or customize the color used on the map. So here, if we, there. So you can actually add more arguments to this. So you can specify if ATMs should appear as red and banks should just appear as yellow. But for now, let's just stick to the default colors that is displayed. Any questions so far? Right. So this one, I am actually spotting something that could go wrong. So what I'm trying to find out, oh sorry, not barangay, which commune is the smallest. So I'm trying to find out which commune is the smallest. So before I run this one, can anyone tell me which part I should replace first? So again, just raise your hand if you know the answer of which parts should be replaced. Also, we'll be giving away treats again. So this part is actually supposed to be an exercise. I know. Replace. Hello. An exercise. So just to raise hands, please to take a guess at which part I should change. I see some people pointing at the screen. Would you like to share your guess? Let me.
I think we need to change the projection from Philippines to Cambodia.
Yes. So that's correct. We actually need to change the projection from the one we use in the Philippines to the one that's supposed to be used for Cambodia. So thank you so much for sharing your guess. You have a small prize from us. Yay! So just to do that, again, I will just replace this part with the projection we're supposed to use for Cambodia, which is this one. So given this part, what do you think this line of code does? So again, just raise your hand if you want to take a guess or share your answer. Any guesses from the audience? It's already highlighted. Yes.
Nói chuyện khắc phục rằng sao cần nhớ tới trên nhà tên là
Oh, can you share with them?
បាទក្នុងកូដនេះបន្ទាប់ពីការកណនារួចទៅវានឹងចេញផ្ទៃកន្លាដែលឃុំទៅតូចជាងគេ
Great. So yes, what this does is it's going to calculate the area of each commune and add it to our data set. So let me run this first. And now, if I display this data set again, so, oh, it's just one. So I'm just displaying the first row. And if I scroll to the farthest end, I have a new column here, which tells us the area in square meters. Now that we have this new column in our data, we can use it to select which one is the smallest. This max. Yeah. So okay. So here, I'm selecting two of them. So the first line displayed here it should be the largest commune in the province. And the second one here should be the smallest one. So if I scroll to the end, we can actually see the area in square meters. So we can make this a bit more readable by, again, dividing this by 10,000 so that it's going to be in hectares. And then if I rerun this, it should be the same barangays, but the area should be easier to read. There you go. So we have the smallest one, and then we have the biggest one based on size. And it is, what is this? Please do. Can anyone confirm if that's correct? Do you agree that these are the smallest and largest communes in Phnom Penh? So our next example here is, let's try to identify which district or city in Phnom Penh has the most number of POIs. So remember this data set from earlier where we combined the POI data with the administrative boundaries. So just to recap, let me show you what the data looks like. So again, it's each POI or point of interest with its name, class, geometry, and if you scroll to the right, it also has the different administrative boundary information, like which commune, district, and province it belongs to. So from here, we're going to get the ID. So this is a unique identifier for each row, and the admin, the name of the commune of where it's located. I can do dot value counts, which is a Python command which counts how many. This should be. Yeah, so it's going to count how many OSM IDs or how many rows are there based if we divide it by commune name. So it's going to give me a list of how many points of interest are located in each commune, such as this one. So we can see that the commune with the most number of points of interest is this one here. Oh. So this is supposed to be Phnom Penh. But there. We want to find what percentage of Phnom Penh is outside 500 meters of a bank or an ATM. So which ones? Okay, let's make this a bit bigger, maybe 1,000 for 1 kilometer. So how much area of the province is more than 1,000 kilometers of sorry. What? Oh. Yeah. Which parts of how much in square meters of Phnom Penh is outside is 1,000 kilometers away from the nearest bank or ATM. So again, to use the POIs geometry, and we projected to sorry about that. So I want to use the correct projection again. Oh no. Number again. 326. So here, what I'm doing is setting the correct projection for our POI data and then drawing a 1,000 meter buffer around it. And the next is, so once I have this data set, so let's just see how that looks like first. As you can see, they're no longer points. They are now a collection of circles that overlap with each other. So this denotes the different areas that are within 1,000 meters of a bank or an ATM. So our next step here to answer that question is combine all these individual circles into one big shape. So here we're going to use the dot dissolve function to do that. And now, if I plot this, it's going to look the same. So it looks exactly the same, but if I print the whole data set, it should be just one row in the data. As you can see here. Unlike if it's this one, the original one that we have, it's going to be multiple circles, as you can see here. So now that we have this POI's buffer where it shows us the areas of the province that are within 1,000 meters of a bank, any guesses as what to our next step should be? Anyone from the audience? Nope. Okay. So the next one we're going to do is actually a spatial predicate. So it's going to be getting the symmetric difference. So I know this wasn't covered in our discussion earlier, but what it does is if you stack our two data sets together, it's going to do sort of a subtract from the layer. So all the areas that intersect from those two layers will be removed. So as you can see here, if we do symmetric difference, where is this coming from? Here is not found. Oh. Where is that number again? There you go. So you can see the Phnom Penh GDF. So this is the whole province. If I plot this, it shows the administrative boundary of the province. And going back to, where is that plot? Going back to this one, as you can see, if we layer this on top of each other, all the areas that intersect were removed from our resulting analysis, as you can see here. So now that we have this one, let's try and get the area. So here, let's divide this by 10,000. Okay, so here I have a first part where I am getting the area of this one right here. So all of the parts of the province that are outside 1,000 meters from a bank. And then here I'm just getting the regular area of this one. So it should give us a percentage. So it should give us a percentage of how much of the province is beyond 1,000 meters from the nearest bank. So here we get the answer, which is 45% is actually more than 1,000 meters away from the closest bank. So that's actually the end of our introduction to using GeoPandas. You can explore this next section here, which is another solution to getting this one. So it should give us the same answer. Diba? Area. DISGDF this solve. CRS. Anyway, yeah. So that concludes our session for working with vectors. We do have another module for working with rasters, but since we're set to end at 4:30, we'd actually just want to go do a demo of this one instead, rather than diving into details. And then we also want to leave some time for you to ask questions or explore more other things that we can do with GeoPandas. Okay, so wait, let me open that here. So here, I've set up this one. So we're also actually using Google Earth Engine for this one, but just as um, uh, this one, I will just be demonstrating it instead of everyone following along, since I know we still have a few GEE setups that we have to fix before doing this. Okay. Okay. So there are some questions about GeoPandas. We can go through this first before we start this one.
Yung sa notebook ng GeoPandas, hindi na nagmamatch yung number.
Yeah, hindi nga nagmamatch. Okay, we can fix that one.
Yeah, we could, there's that. I think some people are.
Okay. Sige. So some of you noticed that in the last solution, the numbers don't match. Thank you for being very observant. Oh, wait, let's scroll to that section here. So in our original solution, it's 45%. While in this one, if we multiply this to 100, it's going to be just 41%. So there's a discrepancy. So this was actually a solution submitted to us by one of the previous participants of this session. So we can go through each step to identify where the error is coming from or the mistake in calculation. So what it does is it's going to subtract the area of the buffered POIs with the NCR area. So instead of doing all these geometric transformations where we do a lot of dissolves and a lot of subtracts, we're just going to use the area of each one. So here we have the Phnom Penh GDF, which is our data that represents the province, and we're setting it to the CRS. Is this the correct? Yes, we are setting it to the CRS we use in Cambodia, and then dot area. So if we print this alone, if we run this alone outside of this long code here, it's going to give us the area of Phnom Penh. And then the next part here is it's subtracting the POI's GDF area. So again, let's go through this by parts. So here we have the data frame for the POIs that we transformed into buffers or the circles from earlier. This one. And then we are again dissolving it into create just one polygon. And then we are getting the area of that one. So if we run this on its own, at the bottom, So we're also getting the area of the dissolved POIs. So here we see that we're supposed to subtract the two to get the difference. So just adding a minus here and then pasting the same code that we ran earlier. And this gives us the difference in size of these two. So I think, and then to transform this into a percentage, we're going to divide it again by the size of, the total area of Phnom Penh here. So right now it's going to give the same number. Nah. What? A bit hard to read. I think this is an old case of not using PEMDAS. That's why it's different. So here, what I'm doing is, this is quite a similar code from this one. So we are getting the difference in area of Phnom Penh province minus the area of the buffered POIs, and then dividing that number by the area of Phnom Penh to get the percentage. So here, meron din. Symmetric difference. Overlap. Okay, so we can't seem to figure out where the extra 4% is coming from. We'll look into how symmetric difference works. We think it's because of the overlap. Parang mali. Parang hindi yun. Yeah, so we'll get back to you regarding this one tomorrow. But is there any other question about GeoPandas? Or Python in general? Yeah, pwede. Sige. Wala tayong recap slide. Any more questions? I promise I will investigate this later and get back to you why it's different. it was the same for NCR. Okay. What? Slide me. Yeah. Dito, parang ayoko na. Capture na lang siguro into, what na? Not yung wrap up.
Okay. Yung ano, so,
What? Aling original? Yung outline.
yung outline.
Wait lang.
Outline ka siya.
Hindi ko na na-cover yung okla. It. Layo.
Yan.
They can
No?
answer. They can answer yung survey while we wait.
Okay na.
Okay. And then ito. Fuck.
Meron na yan. Okay.
Nasaan na yung cursor ko? Ayun. Wala yung cursor. Ayan. There. So, just recapping what we were able to discuss for the day. So we started off with the project introduction, where we discussed how we used GIS and machine learning to estimate rice yield from satellite images and open data. Next is we went over some open data resources, what open data is and how we can use open data as part of our day-to-day work. And then lastly, we covered geospatial analysis in Python. So we went over what GIS is, how it works in Python, as well as did some hands-on exercises for vectors. So we did also prepare some examples, discussions and activities for you on how to handle rasters in Python. However, since we will be ending the session for today at 4:30, I'd be happy to send this as additional references for everyone so that you can go through the exercises in your own time if you want to explore how rasters work in Python. So for tomorrow's session, we'll be covering of machine learning. So there'll be more books and more Python, but this time we will be attempting to create our very own machine learning model. So we'll start off with some feature engineering using, we'll walk you through how we use different Python libraries to create model inputs so that we can create a model and predict wealth estimates. So tomorrow we're going to build a model using demographic health surveys, wealth estimates, using DHS data, speed test data sets, as well as nighttime lights. So, and through that, we will also walk you through the different steps on how to create your own machine learning model. So I hope you are excited by that. So thank you so much for going through all of the activities with us. So we know there were a lot of hiccups in our session, and we'd love to hear your feedback. Please visit this link here. We'd love to hear your input so that tomorrow we can come more better prepared and run the session more smoothly than earlier. Thank you.
Okay, so there has been a lot of topics, discussion, exercise. I mean, thanks to Ren, there was a detailed step-by-step sort of the exercise also. And I think there will be other follow-up material for those of you who would like to revisit the exercise. I just wanted to get raise your hands. Are you listening to the interpretation now? Who is making use of this interpretation? Oh, I don't. Do I need this? Oh, okay. You don't understand. Is it a good idea to have this? Is it easier? Is it easier with the? Is it easier to follow with the interpretation? Those of you who think it's a good idea,